For centuries, humanity has dreamed of transcending the boundaries of space. From the first steps on distant continents to the silent wanderings among the stars, the longing to move instantly from one point to another has never faded. It is an ancient dream, the idea of teleportation, what once existed only in myth and imagination, from magical portals in folklore to the transporters of science fiction, has, in recent decades, begun to shift from fantasy into the realm of science. The discovery of teleportation technology is not the story of a single moment, but the culmination of centuries of exploration, theoretical breakthroughs, and the relentless human desire to understand and control the fabric of reality itself. In this journey, we will explore the origins of this idea, the milestones of its scientific evolution, and how, today, teleportation is no longer merely a metaphor, but a physical phenomenon that challenges the very meaning of distance, time, and existence. The word teleportation was first coined in the early 20th century, combining the Greek prefix tele, meaning distant, and the Latin portere, to carry. But the dream it represents is far older. Ancient myths from cultures around the world tell of instantaneous travel, from shamans who could appear in distant lands, to gods and spirits who crossed worlds in the blink of an eye. In literature, teleportation appeared as both wonder and warning. It symbolized humanity's hunger for transcendence, the wish to escape physical limitations, and the curiosity that drives discovery. By the time science fiction matured in the 20th century, teleportation had become one of its central motifs. Writers such as Arthur C. Clarke and Isaac Asimov imagined machines that could disassemble a person molecule by molecule and reconstruct them elsewhere. But while fiction played with imagination, physics was quietly building a foundation. The advent of quantum mechanics in the early 1900s, with its strange laws of uncertainty, superposition, and entanglement, gave scientists a new way to think about information and matter. It was here that the seeds of real teleportation were planted. The first scientific discussions of teleportation did not involve moving objects or people, but information. In the quantum world, particles can become entangled, meaning the state of one instantly affects the other, no matter the distance. Albert Einstein called it spooky action at a distance. For decades, entanglement was viewed as a curiosity, something that seemed to violate classical logic. But in 1993, a team of scientists, Charles Bennett, Giles Brassard, Claude Crapo, Richard Joza, Asher Perez, and William Wouters, achieved something revolutionary. They published a paper demonstrating that quantum teleportation was possible, the transfer of the quantum state of one particle to another, across distance, without moving the particle itself. This was not science fiction. It did not involve the physical transport of matter, but rather the transmission of information that defines matter's quantum state. By using entanglement and classical communication, they showed that an atom's quantum properties could be destroyed in one place and perfectly recreated in another. In essence, teleportation, at least in the quantum sense, had become real. Following the 1993 breakthrough, laboratories around the world began to test the concept. In 1997, the first successful quantum teleportation of photons was achieved by Anton Zeilinger and his team in Austria. 2 years later, teleportation of atoms followed. By the 2010s, quantum teleportation experiments had extended over increasing distances, from a few centimeters in labs, to kilometers through fiber optic cables, and even between Earth and orbiting satellites. In 2017, Chinese scientists successfully teleported the quantum state of a photon from Earth to a satellite over 1,400 kilometers away, marking the beginning of what some call the quantum internet. Each experiment pushed teleportation closer to practicality, not as a means of moving people, but as a way of transmitting pure quantum information instantly and securely. The implications were staggering: unhackable communications, distributed quantum computing, and entirely new paradigms of data exchange. But while the scientific world celebrated these milestones, the public imagination raced ahead. Could teleportation ever be applied to humans? Could we truly transport ourselves, body and mind, across space without traveling through it? The answer, for now, lies somewhere between physics and philosophy. Teleporting a human is not merely a matter of scaling up technology. A single human body contains around 10 to the power of 28 atoms. To teleport such an object, every atom's quantum state would need to be measured, transmitted, and reconstructed perfectly, an unimaginable task with today's technology. Moreover, the act of measuring a quantum system collapses its state. In other words, observing destroys the very information we wish to send. Quantum mechanics, in its strange wisdom, protects privacy at the most fundamental level of nature. Even if we could overcome these barriers, another question emerges. Would the person who appears on the other side be you, or just an identical copy? Would your consciousness continue, or would it be replaced by a perfect replica that believes it is you? Teleportation forces us to confront not only the limits of technology, but the mysteries of identity, continuity, and existence itself. Quantum teleportation, though far from human-scale travel, has already begun to reshape modern science. Its most promising application lies in quantum communication, a system that uses entangled particles to transmit data with absolute security. Unlike traditional encryption, which can be broken with enough computational power, quantum communication reveals any attempt at interception instantly, as the act of measurement alters the quantum state. This could lead to a future where banking systems, governments, and individuals communicate across unbreakable channels. In addition, quantum computing, a technology still in its infancy, relies on teleportation principles to connect quantum bits, qubits, across distances, enabling them to work as a single system. Teleportation might also revolutionize materials science, medicine, and data transfer. Imagine transmitting medical data or molecular blueprints instantly between laboratories across the world. In a deeper sense, teleportation represents the ultimate form of digitalization, the direct transmission of the building blocks of reality itself. Every great scientific breakthrough raises profound ethical questions, and teleportation is no exception. If, someday, we could teleport people, even theoretically, what would it mean to destroy one body and reconstruct another elsewhere? Would that act constitute death and rebirth? Would society allow such a process? And how would we define identity, ownership, or even crime in a world where movement has no physical boundaries? Religious and philosophical traditions have long wrestled with the nature of the self. Teleportation, by its very nature, challenges those foundations. It forces us to ask whether consciousness is purely physical, or something beyond information and matter. In the broader sense, teleportation mirrors humanity's eternal struggle between curiosity and caution, between the drive to explore, and the responsibility to understand the consequences of our own inventions. As of today, teleportation remains limited to particles and quantum information. But the rate of progress suggests that what was once thought impossible may one day become feasible. In the near future, we may witness teleportation networks, quantum channels linking continents, spacecraft, and digital systems. These networks could form the backbone of a global quantum internet, connecting minds and machines in ways never before imagined. Looking further ahead, advances in quantum computing, nanotechnology, and synthetic biology might converge, making physical teleportation conceivable, not by moving matter, but by reconstructing it from stored quantum information. If that day arrives, humanity will face a new era, one where travel, communication, and existence itself merge into a single continuum. Teleportation would not merely be a tool of science, but a fundamental redefinition of what it means to be. Teleportation began as a dream, a story told by ancient civilizations, a symbol of divine power. But through centuries of discovery, theory, and experimentation, it has evolved into one of the most profound scientific pursuits of our time. Though far from the teleporters of fiction, quantum teleportation reveals something deeper. The universe itself may be a web of information, connected beyond physical limits. Every atom, every photon, every point in space, entangled in a grand, invisible network. The discovery of teleportation technology is not simply about movement. It is about understanding that space itself is not as absolute as we once believed. As we stand at the dawn of this new frontier, we are reminded of a timeless truth. Every leap in science begins with imagination. And perhaps, in imagining instant travel, humanity has already taken the first step toward transcending the limits of space and time.